Okay, so let's have a look at another electromagnetics question. Here we have a car battery connected to a split pair of parallel wires, connected to a resistor, connected to a switch. We are told that the force per unit length felt by the two wires in this arrangement, is 0.1 millinewtons per meter. We're asked, what is the current in the circuit? Well, to begin with, each of these currents has to go this way, because we're told the current goes through the circuit this way. Because they are in the same direction, they must attract. So we know these forces are attractive. This is the first thing. If we want to find these currents, we are going to assume that the currents in each of these wires, I1 and I2, are equal. So we are going to say I1 is equal to I2. If this is a standard split circuit, this would approximately be the case anyway. So we have a formula for this. We know that force per unit length is equal to mu naught times current 1 times current 2 divided by 2 times pi times the distance between them. So we don't know current 1 or current 2. If we assume they are equal, this reduces to mu naught I1 squared divided by 2 times pi times the distance. So we need to find I1 in this case. So we can rearrange this. So we'll multiply both sides by 2 pi r. This and this by 2 pi r. This gives us F on L, which I'll keep on its own, times 2 pi r is equal to mu naught times I1 squared. Divide both sides by mu naught, and then take the square root. This gives me the current in one of them, which is the current in both of them, is equal to the positive negative square root of F on L times 2 pi r over mu naught. So now I can just plug everything in, and we'll just assume it's the positive. So we'll assume positive because it doesn't matter if it's a positive or negative, we just need the magnitude really. We have the square root of F on L. This is 0.1 millinewtons per meter. This is not a particularly nice unit. 1 millinewton is 1 times 10 to the minus 3 newtons. So 0.1 millinewton is 1 times 10 to the minus 4 newtons per meter. So this is 1 times 10 to the minus 4, so just 10 to the minus 4, multiplied by 2 times pi times the distance between them is 1 centimeter, that's 0.01 meters. This is divided by mu naught, which is 4 times pi times 10 to the minus 7. So I am not going to manually simplify any of this. This is all going to go in the calculator. Square root of 10 to the minus 4 times 2 times pi times 0.01 divided by 4 times pi times 10 to the power of minus 7. I have 2.23606, 2.236 dot dot dot. So therefore the current in each of the wires is about 2.24 amps. Now, if the current in one of them is 2.24, in this split circuit, I1 plus I2 is going to be equal to the total current. Given that they're both equal, this means the total current, I, is going to be 2.24 plus 2.24. This is 4.48. So therefore the current in the circuit is about 4.48 amps. 4.48 amps. And this is an approximate calculation. But this is good enough in this case. And this is the answer that we're after in this question.